oh, no, I got, yeah, so these three types of grammars are still pretty similar. Like they pretty much, well, well, they differ in only one dimension, and there are many more dimensions. So let's broaden our horizons and see how can grammars be even more different, even though these are already pretty different, but other grammars can be even more different. And also, like, instead of just using different grammars to do the same thing, what can maybe we should do one thing with one grammar formalism and another thing with another grammar formalism, and not just do the same thing with different tools. So that's loosely the point of this talk. So again, I'm not trying to talk about all the features in the world. Like some of these are orthogonal, some features maybe presuppose or prohibit other features, but this is like a very loose overview. So some ways in which grammar formalisms can differ. I'm going to talk about these 5 things. And let's get started. You'll see in time what these things mean. The first thing I'm going to talk about is if the grammar if we're using it for generation or for analysis, or both. So in the case of generation, this is like all of these GF grammars and context-free grammars are generative grammars. So we assume that our grammar creates the language from nothing. So nothing exists before we start writing our grammar rules. And then once we follow the rules, we produce something, and all the things we produce, that's our language. But if we instead we want to follow another approach, we can just say that, okay, there are things in the world, and then our grammar is rules that would find some structure among these random noise, like these. So we don't necessarily generate, we just take a bunch of stuff and then we put it in boxes, to put it abstractly. So let's take a concrete example. So if we want to let's have a task, find part of speech for each of these strings wish. And we can use grammars. We can use generative or purely analysis grammars. They both will do fine. So we know that the right answer is this, that the first one is a verb and the second one is a noun. Let's see how would grammars do that. So let's start with the generative grammar. So this is, I hope that by now you've seen plenty of things like this. Like this is not GF, this is the context-free grammar, but like it's a context-free grammar with the labeled, like the productions are labeled, and in GF grammar it would correspond to the names of the functions, like here. Oh, is it? Oh, for me it shows that I'm screen sharing. Does it? Okay. Huh. Okay. Right. So anyway, so like it doesn't matter, like those two grammars are equivalent. I just show you both ways. But like, so I'm if you're watching this video and you really want to see it, you can pause, but like I'm just gonna jump over it. And the concrete syntax is that. So again, if you want to watch it, just pause. So now we're gonna look at how do we find out which wish is verb and which is a noun. So we do it by generating that sentence from scratch. And here in the tree, the words are disambiguated, so to speak, because the grammar could not generate a tree where the labels were vice versa. Like it would be impossible for it to generate a tree where the first wish is a noun and the second wish is a verb. So it's like, if the only thing we want to do is to disambiguate, then, well, this is like kind of heavy tool for that. It does its job, like by not even generating the wrong option. And then if we start from analysis, so we start from some kind of part of speech tagger that just tags each word without any context. So it gives initially both options to both of these strings wish. And then we have, in addition, we have local disambiguation rules, which look at the local context. So yeah, if it's after an article, it's a noun. So this one disambiguates the second word. And to make it make a bit of a shortcut, we say, okay, if it's not a noun, it's a verb. So then we disambiguate the first one. And right now we have come to also the desired conclusion that we have disambiguated these words. We have only one part of speech tag for each of them. And so we can also say that these rules are a grammar. Like, it's not a generative grammar because it doesn't define all sequences of language, but it's a grammar for creating structure for natural language text. So I'm very happy to welcome it to the gang of grammars. Like, this particular example is a constraint grammar, but like, it's not the only analysis grammar in the world. It's just the one I know best. So that's fine. So if just to illustrate the point, so if we ask these grammars to let's take a new task. So this is not disambiguating. This is now like you press G, you do gr in the GF shell, like give me a noun phrase, gr-cat equals NP. So the context-free grammar is very happy to do that. So it goes to a production rule like this, one of them. It could be the other one was too, but let's choose this. And then it needs to find the ones on the right-hand side. So like, here's an N, here's a det. And then it just follows the rule, put it together. And here's the string, a tree, which corresponds to a string. And this is a noun phrase. So I'm happy. And now if I ask constraint grammar to give me a noun phrase, then it will not be so, it will not give me that if I didn't give it any words that to analyze. Well, technically, of course, you could write such a grammar, but such a program to do it, but like, that's not really how the grammar is constructed. Like, in contrast with the generative grammar, so you have production rules, which that's like literally what they do. They generate things and they give us a tree. So any questions on that part, or right? So let's go to talk about these different kinds of trees then. So again, so why these two? No, these are not the only two kinds of trees in the world, but like, when we look at different grammar formalisms, they're kind of, a lot of them are just have some kind of twist on these basic ways of building trees, phrase structure or dependency. And so we're ignoring the trees or no trees, because like, of course, many practical NLP tasks are perfectly fine using just part of speech tagging, and like there's something called shallow parsing, where you like, the trees are not really like recursive, but you can still have some kind of tag that, oh, VP starts here, VP ends here, but they're not fully fledged trees. But in this summer school, we are very big fans of trees, and it's not like we're not doing practical NLP tasks, we're doing some type theory based grammar formalism. No, sorry, just kidding. We are doing that too. Okay, so the two types of trees I'm going to talk here. So the phrase structure trees have this kind of hierarchical structure. They are also called constituency based trees. So like, we have these V2 and NP form a verb phrase. So that's hence the name phrase structure. It's not just two words, it's a verb phrase. It has a name It's labeled like that. But a dependency tree, it's just a direct relation between words. So love is the head, and there is a dependency from that to the dependent you, and that relation can be labeled. So like this one is labeled as direct object. Let's take the whole sentence now. I love you. So again, we have the phrase structure tree. First, we build a verb phrase, and then from that verb phrase and the noun phrase, we build an S. But the dependency tree is still just, well, there are now two arcs, two relations. There's a root word, and then from that, that root word has two dependents. So it's very much lexicon driven. Right, so this is, here is the same. We just swapped the context-free grammar for a GF grammar for this phrase structure version. So, and why that? Because I'm going to show you next twist. So, yeah, the structure for this I love you is the same. Now we just have these, the syntactic functions are labeled just like in Inari Listenmaa. Okay, so now let's take another tree, you I love. So we have different word order. And now the phrase structure grammar, like I had to add all this stuff here. Like suddenly I added a new category and two new functions to allow for that. So yeah, this new category, which is like, it's not the VP, because VP is like a verb and its object, but this is some kind of ad hoc category for, it's an S missing its subject. Oh no, sorry, yeah, it's an S missing its object. So it's among the 27 slides I threw away was an explanation where does the name slash come from. So, but it comes from categorical grammars. Maybe you don't need 27 slides about categorical grammars. So anyway, so we had to add a new category to put another phrase together, which is the subject and verb without object. Like it's like kind of sort of mentally taxing in a sense to have to make up these new things just to get a different word order. And also, so if we contrast with this unmarked word order, so there is a phrase of two words, but they are different categories and different functions. And also the function that constructs the S is different. So the grammar has to do more work. But the dependency tree, if we look at that, here's the you I love, and then we compare it to the I love you. So actually the dependency tree didn't change at all, even though the word order changed. Like it's still the same tree, like it's just the words are in different order. So this is way how usually dependency trees are represented, like in text instead of pictures. So you start by number the words, and then you just put their head. So in this case, the head of I and you is like the head of 1 and 3 is the word number 2. And in this case, the head of 1 and 2 is the word number 3. But like it's like these trees are basically the same. Like there is no new theoretical things added here. So yeah, lots of different grammar formalisms have one or the other with some kind of, maybe some kind of custom twists. But if you know these two, it's kind of your
the dependency for these two examples will be love I, love you.
Yeah, exactly. The dependency relations, like you have love is the head of I and love is the head of you. Just scramble a bit. But we're going to have actual talk about universal dependencies and how GF grammar relates to them. So like, yeah, not gonna talk more about that because Arne will continue on dependencies. Okay. So this next thing I'm going to talk about is like what kind of, how many levels, kind of layers we have, because like in GF we have all this abstract and concrete syntax. So let's talk a bit more about that. So here's a slide I stole from someone's presentation 5 years ago. This is a talk about English to Kazakh machine translation. Now I stole that slide because this is like the most abstract. This is the abstract syntax of whatever that particular tool, grammar formalism, they were using. And so okay, these trees are right. So these trees represent the sentence. I know that you go to Kazakhstan. So these trees are different because we see that they have almost the same subparts, but they're in different order. And yeah, something like the preposition to in English is just not realized in Kazakh, but so you wouldn't just translate this word to word, like, and they are not doing this here either because they are doing tree transformation. So, right, so this is one way of doing computational linguistics, like you do that. Then let's look at the GFRGL abstract syntax tree of, I know that you go to Paris, because we don't have the string Kazakhstan in the basic resource grammar library. We just, in the mini lexicon, we have the word Paris. So hence the deviation from the source. So now this is like, we have two levels here. This is the abstract. And this is the two concrete syntaxes, one for English. Oh, can you actually see it? Almost. I know that you go to Paris. And then in the other on the right, we have that string in Basque, which I have glossed in English, so that you start with this to Paris, which is actually like, it's not with the preposition, it's with the case. And it's using these bind tokens that we saw yesterday. So to glue an orthographic word together at runtime. Then we have, so instead of that you go, we have just one word again, which is like you're going, basically. This part Soase has, it has like it has the second person singular subject. And then this suffix la is the one that makes it into like a subordinate clause, all in one word. And then finally, no, I know. So yeah, despite it, we've actually we've seen a bunch of trees like that yesterday, but like just to give a reminder, this is two layers. We have abstract and concrete. So this is what GF is doing, two layers. They're also called textogrammatical and phenogrammatical. They're actually, the names come from Haskell Curry. He did a lot of things, not just logic. But then, of course, this is not like the most layered grammar formalism. Like we can always have, like, I'm pretty sure that there is a summer school that is like laughing at us, like, oh, those GF people with only abstract syntax and concrete syntax. Like we have semantics. And then there's another summer school that is like going like, what are you doing with only semantics? Like we're doing everything from phonology to discourse and pragmatics. But again, this is not any particular formalism I know of. It's just, no, that's just a design choice. Like, not sure if all of these exist in any particular one, but yeah. And so this, So this is the previous one was very closely related to multilinguality, because again, we look at this, like if the highest abstraction level is on the level of concrete syntax, then okay, so we can actually do very useful things. Like we can do a pairwise machine translation with tree transformation rules like this. And this kind of machine translation can be very successful, and it can definitely require less hassle than trying to fit like 40 or 300 languages into one abstract syntax, like the RTL.
Just to get one thing right, you said that the right one is the correct Kazakh, so grammar or the correct syntax for.
Yeah, at least according to this. Like I stole this slide from someone's presentation who, like, that's supposedly what their machine translation system outputs. So, or at least output.
The left is the sort of the way it would look in English, but this would not be correct.
Yeah, exactly. Like, because in the English one on the left hand side, like they have put the words have been translated into the target language, but the syntax is still English syntax. So then they do like a tree transformation on the tree to get the correct target language syntax. Yeah. But yeah, like, so I'm not here to bash other systems. Like this is like definitely people can be very successful in this. Like we had yesterday in the evening lectures, like we were talking like half an hour about how the RGL is kind of problematic for when we add new languages, and how it can be a headache to actually like make it fit for like these new languages. So there's certainly positive sides to trying to be less ambitious and abstract, but so it depends on application. So if you want to translate between Spanish and Catalan, then like it's going to be very easy to make a pairwise system that is like very close to the concrete syntax, because those two languages are very close to the concrete syntax. And like I bet someone probably has done like a neural net that just would do just like transform words by regular expressions. Actually, no need for neural net. They can do like, but yeah, okay, sorry, it's not like that. But anyway, so if you want to do between closely related languages, one pair, then don't go for GF. It's a lot of hassle. But if you want to generate text in many different languages from different language families, like, then it's a good idea to do that. So yeah, in that context, this is the abstract syntax is an interlingua, and the concretes are these different languages.
But yeah, so I mean, the interlingua is nevertheless inspired by the English grammar. So it looks very.
Yeah. So that's one of the criticisms. Like, so what like Arna said yesterday, that like the RGL abstract syntax is designed to be the intersection of language constructs, and like, so I mean, okay, it is true that like it like how the tree branches, it also mimics the English word order and the phrase structure, like we saw yesterday. If we had made an abstract syntax like inspired by Somali, like those trees look very different. But yeah, I think also like, so English words is pretty much a convention, because like you can assume that everyone understands, like, so that the names of the leaves are like English words, or in the case of WordNet, they're like word underscore number underscore part of speech. But yeah, like it's definitely inspired by English. But like the point is just that it's supposed to be, the concepts are supposed to be abstract enough. Like we assume that you can somehow modify a noun. We can assume that you can somehow put together a verb and a complement. And that might not happen in the same order as in English, but like here, like, yeah, go to Paris, like we have go to Paris, go. Yeah. Yeah, I don't know if there is like any attempts to, because I mean we have, so we're going to have a talk about the Portuguese grammar for HPSG later today at 8 p.m. and that's an example of a monolingual grammar. So they are not using an abstract syntax based on English. Like that's a standalone grammar that is designed to be able to represent Portuguese as well as possible.
Yeah, I mean, I guess we are not sure that most Indo-European languages sort of have very similar structures to English. Yes. So converting among the European languages is probably not such a problem. But well, what happens if you have two completely different language families and you map them via some European language?
They were saying that like by changing the even the mapping, like the whole order just will make sense. But I guess when they read the RGL, they seem like all languages have adjective, all languages have noun, all languages have verb, you know. So,
yes.
So then there was this South African lady who was explaining that it becomes very difficult to put a new language to force it into the challenge of force it into the existing structure so that it can be usable in the
Yeah, so like in one way, like, so it's also, we can make a decision, like how do we interpret adjective? So okay, we can, if we look at the abstract syntax of the RGL, we have a category called AP, and it's used in two functions. It's used to modify a noun, and it's used to be a predicative. So like boring pizza, and pizza is boring. And then when we do a resource grammar for a language that doesn't have such a, like that kind of notion, we can just decide, okay, so we just put there whatever does these two things. Actually, I think there was a Lingthusiasm episode about adjectives. It's a linguistics podcast. I'll link it later, maybe. But like it's definitely a fact that like what we call adjectives, like if we just like if we make the category to like too strict in the sense that okay, it must be just like the adjective in English or like French, then okay, sure, many languages don't have like that. But anyway, if we look a bit more abstractly, like there are a lot of things, like I think lots of languages can have some strategy to modify a noun and to predicate, to be a predicative, like be a property, quality of something. And then we just shove those in the AP category in GFRGL. So that would be the answer.
Do you have concrete examples of how to
yeah, sure. Yeah, okay, sure. I mean, so like, so I did Korean resource grammar, and so in the Korean resource grammar, it's like the linkage of adjective and verb is basically the same. And then, so when the verb is, when the adjective is predicative, then it's just like, you know, instead of saying that the cat is green, then it's just the cat greens. And then when it's a modifier, like the green cat, then it's like rather the cat that is green. So that's a very simple answer to all the languages where it's adjectives are verb. And then we can, so the benefit of just like shoving it into AP is that we have easier API for, because if you want to translate the English adjective green, and then you can just, you know, that the green underscore A in Korean would be something that is a proper translation of green A, but it just internally behaves as a verb, but the English speaker doesn't have to care about it.
Is that the fact of not distinguishing between, let's say, adjectives and verbs only on the lexical level. So that green can be used as a verb and an adjective, or is that really structural? Because I mean, there are verbs which one can hardly imagine to be turned into a property. They're like verbs expressing go or something.
I mean, that goes, or like, I mean, yeah, I mean, also like a lot of languages would have like some difference between stative and active verbs, for instance, like, yeah, but so like, so it's like also like you can choose to do so that in the lexicon of your language, you put these things that might semantically be translated as adjectives in English, you might put them into the category verb in that lexicon, and then you can just use, because the RGL also has the syntactic structure for relative clause. So you can say in the RGL, like, you know, like Inari who is giving a presentation, and they're like, give a presentation is definitely a verb phrase, but you can choose to modify a noun phrase with that verb phrase by making it a relative clause. And then in another language, like, I mean, in a lot of languages, like in Basque that we see right there, like that would be, that relative clause would go before it, like the presentation giving Inari, like. And then it's like not that far from just like in English, adjectives go before the noun, and like, it's not such a stretch to do that. But yeah, it's definitely, I mean, it's always like, I mean, I'm not denying it's like, it's a lot of like effort to shove a language that it's not such a standard average European. Like I talked an hour yesterday about just adpositions. Like it's definitely a lot of effort. I just believe that like I don't really care that much like what the interlingua is based on. I just believe it's kind of useful to have one, and yeah, if we design one now, maybe it could be better, but like we have this one for 40 languages already, so like kind of. But yeah, I know that I'm very biased because I'm kind of invested in this already. So but yeah, I'm certain that it could be better. Like, okay, so now let's talk about this. Actually, this talk is going to be actually much shorter than the rest of, because that's what you get when you throw away 27 slides. Great. I don't regret. That was a good decision. So let's talk about this, expressivity and complexity. Okay, I know, Martin, this is like, you can like wake you up at 3 a.m. and you can just answer perfectly this, but okay, so let's start with this. This is a classic, rather unhelpful answer on Stack Overflow about formal language theory, or rather, how do I parse HTML with a regular expression? I'm not sure if I've even seen the original question. It's like the answer is the one that is the classic. But yeah, someone on the internet is trying to parse HTML using regular expressions, and doing that they summon Cthulhu. But there is a hint at an actually helpful answer. So before all the Cthulhu stuff, so it says that regular expressions are insufficiently sophisticated to understand the constructs employed by HTML, because HTML is not a regular language. And what does that mean? So this is called the Chomsky Hierarchy. And so this is not a formal introduction topic, so I'm just gonna hand wave to give you a rough idea. Please consult other sources if you want to get more than a rough idea. So the idea is that like the language is more up there, are more complex, and the language is more down here, are more simple. So complete hand wave, like these are not in the right places, but yeah, like with regular languages we can recognize and output, why not, very simple languages. And maybe with context free, we can, like, if we want to pass HTML, we actually, like, properly, we would need to use a context free grammar. And then if we want to do all this bunch of legalese, maybe we're better served with some grammar formalism that goes a bit beyond context free, like GF, for instance. But this is also hand waving. This is not like an exact spot anywhere, but just to give you an idea. So yeah, it says in the GF tutorial, I'm just quoting directly. So separating concrete and abstract syntax allows 3 deviations from context-free grammar, which is permutation. So we can, in a production, like we have these things on the right-hand side, we can swap the order, we can remove them, and we can repeat them. So that's not something that context-free grammars can do, but because in GF we separate the abstract and concrete, then it's like we can do more things to the arguments of these functions. And here is a standard example of how we can do languages that are beyond context free in GF. So this is a grammar for doing like exactly as many A's, B's, and C's. And we do this because in the linked we can have discontinuous constituents in this records. So at each application of this add ABC, we add exactly one of each letter in the right place. And then so right, these ones come from the first application, and these ones come from the last one, and so on. And then when we apply this to S function, then it puts the string together, and that's how we get this A, B, 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 C, C, C. So now, which one is the, if we talk, let's relate this more to the natural language processing grammar engineering again. So this first one is not really the right question to ask, because like whether we can output or accept some given string is not interesting, because we can definitely use a simpler language to output all the strings that are part of the more complex language. So in these, like the first language is definitely in the, the first string here, the AABBCC is in the more complex language, but the simpler language also accepts strings that are not in the more complex language. So with the power of regular expressions, we can't accept only one, but not the other. Like either we accept both, or, well, yeah, there is like, I mean, of course, we can always specialize. Like then we could make a regular expression that accepts like literally 2 A's, 2 B's, 2 C's, but like that's not very pleasant to write. So, but with the power of GF, we can discriminate between those two. So the relevant question is, how can we systematically distinguish between valid and invalid strings? And then also as a practical grammar writers, how easy is this for the programmer? So there might still be that, like there are many cases that, okay, we maybe can do the same language in different formalisms, but it's easier, more elegant in the other one. And I'm going to spend the rest of the talk, let's do a bit of live coding to try to emulate a GF grammar with context-free grammars. I haven't found the right answer, so let's arrive to the right answer. Maybe it's actually super easy and I'm proven wrong. Okay, so we did last week, I think it was exactly a week ago, we did this reflexive construction in English. And I remember like you were asking like, what's the point of doing it like we did in GF? So then I was giving some hand wavy answers, and I thought, let's investigate this today. So here are some positive and negative sentences. Our grammar should accept or even produce the positive ones, and it should reject or just fail to produce the negative ones. So let's put in first some just standard standard transitive clauses. The cat ate food. I saw the cat saw me. And then also you saw yourself, the cat saw itself. And then on the negative side, we should not mix the wrong agreement in the relative pronoun. So we can't say I saw itself, nor the cat saw myself. And then we also need to respect the word order. So we can't say yourself saw the cat. And we also need to respect the case even. So we could put another negative test sentence like the cat saw I. But let's just start with this four. So positive set, negative set. And I have already written the GF grammar. And as expected, okay, so this grammar is just like, I think it's pretty much the same that we wrote on Wednesday, but I just removed everything that was unrelated to reflexives. I might have changed some names, but like, no, it's pretty much the same. So as expected, we parse the cat ate food. I saw the cat saw me. You saw yourself, the cat saw itself. And here the reflexive construction is made with this special VP here. So there is like the actual reflexive pronoun is not an argument, like it's not a lexical argument, it's just the string is inserted from the refl v2 function. What's the mouse go? And then finally, we also know that like these are all rejected by this grammar. So let's take a 10-minute break and then recreate this in Python NLTK using context-free grammars with, we can allow ourselves to use feature structures in context-free grammars because that makes it a slightly easier task. So, but 10-minute break and then let's continue. Hello, we're waiting for people to update the computer security something. So we're taking a bit longer break than just 10 minutes because people are not back yet. Yeah, I know. Oh. Welcome back. People have gotten their laptops fixed and a security update or whatever. And now we're going to do some live coding with Python. Show my screen. Okay. Put this. Okay, you can see my screen. Great. So right, as you can see, this is where we were. This the cat saw itself. This is the reflexive construction, and we can. Am I sharing my screen? Yes, and I'm not muted. Great. Yeah, and again this. Yeah, the word itself comes from the VP, not from any lexical node. So, and that was so I chose this because there was discussion on last week, Wednesday, why choose this? And I'm arguing that this is kind of nice and elegant way, and I'm hoping to, well, I'm trying to discover how easy it actually is to do in another way. Like maybe I'll prove myself wrong. Like I'm just thinking this is a good way because I'm used to it and it's equally easy in Python. Okay, so I have prepared a bit here. I have a Python module that is using NLTK, Natural Language Toolkit. It's using the context-free grammars and feature structure grammars. So let me just run the Python code. So Python code reflexible time. Is the font size good, by the way? So, okay, so the first one, this is like the most simple dummy naive grammar. Like this is obvious that it's over-generating. So this is all very standard. Like S is a noun phrase and verb phrase. Noun phrase is determiner and noun. Verb phrase is transitive verb and noun phrase. Then we have some determiner, some lexicon with nouns and verbs. I put them all in past tense, even in the GF, so that we don't need to care about the I see, the cat sees. Like we just do I saw, the cat saw, I ate, the cat ate. And then I put these pronouns all as noun phrases, and then I also put food as a noun phrase because I wanted to make it into a mass construction, just to make it a bit more interesting. Like, this is actually kind of irrelevant, but like I just felt like doing it. So in GF we have a mass construction; it's a constructor, and here we just have the string food is directly an NP. Okay. Doesn't matter. Okay. So now we have our test sentences. These are in the Python code. So the good sentences: the cat ate food, I saw the cat saw me, you saw yourself, cat saw itself. And the bad sentences, we should reject these. So these grammatical sentences should pass. All of these are passed, so that's good. But then, of course, ungrammatical sentences should not pass. The star is like that's a convention to show ungrammatical output or input. So that's what the star means. But yeah, it's very happy to parse I saw itself, the cat saw myself, yourself, so the cat, myself, so I. So, but yeah, as said, this was the naive baseline. So then let's introduce feature structure grammars. I actually I don't know if this makes any difference in the expressivity, because I suspect that like this would just, you can always just make more productions. Like this is just a shorthand, because I don't think this changes anything, because it's still a context-free grammar. You're just gonna like lump them together. But if I'm wrong, like if anyone watches this like 2 years after the fact and points that I'm wrong, like please correct me. So now we have introduced person. So we say that I, me, and myself have the feature singular 1. And then yourself and you have the feature singular 2. I'm just ignoring all plurals here, just to be simple. And then itself has singular 3. And also anything that we form with determiner and noun has this singular 3. Again, because we don't have any plural nouns here now, because I'm simplifying a lot. And then also the noun phrase food is also singular 3. And yeah, and also this person propagates also to verb phrase. So that the verb, like the transitive verb doesn't have an inherent person, but it comes from the object noun phrase. This is actually, you'll soon see why this abstraction is kind of wrong. Oh, actually, yeah, do you have guesses? Why is this wrong? Why is this too naive?
So, because also the verb phrase sort of depends on the person, I would say, isn't it?
Yeah, I mean, like, I just mean, okay, so the VP gets its feature from the object, but like, so this, what this means, okay, so the cat ate food is fine.
What about the eat itself?
But then actually, like, suddenly I saw the cat and the cat saw me, don't parse anymore. So like we can still parse the you saw yourself, because like that's you here, and so SG2, SG2, like this matches. Like this rule is like specifically made to just accommodate for the reflexives. Like that's why I added these normal transitives in the test set, because otherwise we would have been done with this.
So if you write down grammar in this teacher grammar style, so how is that? Is that can that be manipulated by GF or?
I mean, not directly. I mean, this is like, I mean, this is just the way it's written in the Python natural language toolkit. Like, I mean, obviously you can always manually translate this into GF code, but as far as I know, there is no plugin that would do this. So I'm just like, my goal is to find, like, emulate this, like GF grammar that only outputs grammatically correct things, and write similar grammar using these feature structure context-free grammars in Python and LTK. Yeah, so right, so we already, so with this is the second iteration, like not quite as naive as the first one, because I did add the person requirement, but that had the added feature that suddenly it can't parse anymore. I saw the cat and the cat saw me, because it was like too heavily, because it made so that, because here we have the S rule, like that these person needs to match, but actually the person in VP comes from the object noun, and it's all fine when it's one of these, like myself, yourself, itself, but then it means that the cat ate food is fine because they're both cat and food are third person singular, but like then you can't say I saw the cat, because I is first person singular and cat is third person singular.
Yeah, but at the same time, well, this is not visible because we have past tense. But so
yeah.
Third person singular.
Yeah, we can definitely, we can add that too. That's fine. Let's add that as well. Yeah, and so this grammar is almost good at rejecting the ungrammatical sentences, but this is kind of ignoring the case, because like this still allows myself, so I, because they're both first person singular. So okay, so let's do grammar engineering in Python, and let's make this. Now let's be ambitious and let's do the two things that you said. So let's make grammar 3. This is not like a yeah, I don't even know what am I really proving with this, but it's just like trying to show you different flavors of grammars. So let's make grammar. Sorry, there. So grammar 3. Also 3. So now parser 3 is just the same as, sorry, grammar 2 and grammar 3 are just the same, but let's add some features. So so in GF, what we have this thing here, which is like the V2 becomes VP, and then in the concrete syntax, the linked of VP is this. The S is, so again, like this is also a simplification because we just had the past tense. So the S part is the one that has just, that's the actual verb, like saw, ate. But the complement is like the one that is myself, yourself. And when we have these two complementation functions, like two functions that create the VP. So this one, so it keeps the V2 intact and it adds a complement field. But in this case, it means like we just say that like we completely ignore we ignore the agreement and just choose the accusative from the noun phrase, from the object noun phrase. But here we put this reflpron, which is the table like here. So this is definitely actually many more lines of code than what we have so far in this grammar, but like the sort of the positive side here is that the API is very simple. Like if you're using this, like you can just be sure that both of these VPs that we construct will behave correctly. So let's add. We can start. Let's add the inflection actually. We can start from something, adding something to both. So now let's, instead of having past tense, let's do eats and sees. So a new param. Singular 3 verb prom, other verb prom. Now we need a new linket. A new upper. Table here. Oh yeah, we need to also change these. So now it's C8. But I guess. Yeah, we need to also translate between the MP, so agr to the form mp.a, and then we just add that function. now we have the sees itself.
AGR to BF will decide whether it sees itself or see themselves. Is it?
Yes, exactly. So this is like this is the complete list of what the GF grammar produces now. Let's do L back. Actually, no, it's easier to read without. So cat sees itself, food sees itself, the cats see themselves, the cat sees itself.
Do you see themselves on the last 4 lines?
Oh yeah, oh all right. Oh, that's true. That's because it's the right, that's the singular say. So let's add a special case. SG. That's right. Yeah, so this is the singular they and this is the plural they. So. All right, so like the trick that I've been using here is that in the GF grammar, we have the linkat can have as many fields as possible. So that's really the one of the powerful things, because I have in verb phrase, I have some, if this is the one that is like see or sees, and it's only 2 things. Eat, eats. Like you don't say have a different form for I eat myself, you eat yourself. It's just the yourself and myself is different. So yeah, maybe I want to, let's see if we can emulate this in the Python grammar, because I think if I want to, like, I'm just taking the inspiration from the concrete syntax in this. Like, I didn't plan this, so like, let's make a new one, new expansion, new production, NP. So this one should be just, is this how you do it? Let's keep this. Let's see how it works. So I'm gonna separate the types. I'm gonna make sure that we don't make a VP out of the reflexives. Maybe that should work. So it's like in the GF, like actually I have 2 functions. Like I have a compl v2 and a refl v2. So and these both produce a VP, but I can't just like I can't put any parameters into the VP because in this Python thing. So I think I'm gonna have to make different like explicit categories here. So let's make the reflexive rule. We might tweak this later. So reflexive, and this one should be the reflexive. So now we put person is P, and then let's put B2, and then refl NP. Okay. So let's put this into any. And now I'm gonna refl NP. I'll separate these. No clue what I'm doing, but see if this is enough. Yeah, now actually the me is like really irrelevant. Like we super don't care what me is, because this is just an object pronoun. It doesn't affect anything in the any agreement. So let's see if we can just say that's just an NP. Just as even compile. Okay, there's expected open bracket or identifier. Like this. I'm going to do this. Expected value. P1, 2. Possible structure. Let's look at some documentation. How do we underspecify things? Yeah, okay, so we do have something here that is not specified. So what's wrong there? Yeah, we can underspecify. Here is only tense past, but sorry, this is like I'm able to pass line 5. 1, 2, 3. No. Oh, maybe it doesn't like actually comments there. Yeah, okay, it doesn't like comments after that. Oh. Yeah. Okay, so it likes this. Okay, that's good. Okay, so it actually got better already with this because it can't now. It doesn't erroneously parse myself so I. But what does it do here? Cat ate food is fine. Cats on me, you say yourself. Cats on itself. Okay, so maybe this seems like it's doing the trick because we separated the constructors here because like now these two work. And I saw the cat and cat saw me because this is no longer relevant when you do like anything. And then we split these out in REFL NPs. So it was pretty easy fix, but like now we have one more category. Like in GF, we don't need a special category for this REFL NP. How about let's do the verbs now? So if we try to do this so on 8 or oh yeah, actually we should change this because this is no longer relevant. Oh no, actually let's change this because now it comes from right. So okay, now we're gonna do the person agreement also in the VP level. So let's call it sees eats. So now we need to duplicate this. See eat. Not quite sure if we need to So this is okay. This should be easy. This is just the person is SG3. C is eats. And how about we don't put anything, so then it's C eat. So now let's change the, let's take new sentences good. Change the test sentences. C is itself. Okay, does it work like this? Oh yeah, look at this. So we have, this is the new grammar. So old one had, oh yeah, okay, only 15 productions, and then, I know, sorry, so, okay, this is the first one, grammar 1, 15 productions, the simple one. Grammar, oh, where's grammar 2? Oh, did I replace grammar 2? No. I thought I copied it over, but oh yeah, because I don't print it anymore. That's why. It's just there. So right, so yeah, so the first ones, there are 15 productions, 18. So that's how the grammar looks at the moment. We have two ways to make an S. One is the standard one with MP and VP. And the other one is the special reflexive construction, where we have a V2 and a refl NP. And then refl NPs are these things. And so to be more exact, okay, so now actually I think we might have some more issues here. We didn't handle case properly. So let's add another sentence bad. The cat sees I think this doesn't handle it yet. Yes, so so this is not handling case yet properly. Because we only separated reflexive NPs from other NPs, and then we only made those that are possible subject NPs to have this person like feature, but we didn't do anything to discourage them from becoming the object here. So we need to add a case now. So we need to duplicate these entries again. Let's just modify this grammar 3. So I'm gonna split this into subj NP and obj NP. NP here. And so I and you are only subj NPs. So now these can be both subj and obj. So subj NP and obj NP. Yeah, this doesn't really matter if what is the person here. Maybe it's clearest if I don't put the feature where it's not necessary. And now me is only obj NP. I don't know what's a good way to put this together, but now we give opt np only to this, and then subj np only here. And these don't need to change. So let's see. Oh, what's happening here? Oh, what's happening? I know. So okay, so now it fixed the cat sees I, but now what's happening here? I don't know. We have 20 productions. Oh, yeah. Yeah, I think I forgot to add the subj np here. So that's just yeah, that's the only problem. Because there is nothing called np anymore. Subj np here. Okay, so I think now the test set it's parsing all of it and it's rejecting all of these. So, so in order to make this do the same as the GF grammar, we had to split the category of NP into 3. And yeah, that's pretty much what we did. And we added 5 new productions, and we have some duplicated things because like now these are like, we don't have a nice inflection table like we have in GF. These are just completely different productions, and just these are underspecified, and these are like we're just like, if we had more morphology, then we would of course like we would need to repeat these for everything, and there would be no connection with it. So that's a bit of a hassle, but luckily English has very little morphology. So yeah, that's not a fair comparison because like I'm very used to writing GF and I'm not very used to writing this, but like it was not as painful as it could have been, but like I think I still stand in my stance that I prefer writing GF.
But I mean, well, so the question is there any form of comparison between GF and the feature grammars? So could you sort of you grammar you translate it to GF, for example?
Yeah, I mean, like,
systematically.
I mean, certainly you could. Like, I don't know of any tool that could do that. But like, so I mean, so there is actually, so GF can actually read, like, GF can read context-free grammars in, not in the Python NLTK format, but there is, let's see, like, this is one way of writing the foods grammar, like this. Like, we can just copy this into.
Because in the feature grammar, you technically build up some constraint system.
Yeah, exactly. Yeah.
And there were things like unification grammars. Do they use unification, these feature grammars? Or?
Yeah, I guess so. Like that's I still have the to answer that I haven't researched the topic, but like okay. Yeah, I have like going here. Because this is like we have a talk this evening about HPSG. I think like they have this kind of feature matrices, and that's going to involve a lot of unification. But yeah, I have like no clue how it works. So maybe maybe tomorrow, if there is any questions about unifications, I'll know everything about it. But yeah.
Because well, in GF you take your what's the table and you carry it over to other branches of your syntax tree, and then you grab the information out of the table.
Yeah, exactly.
And so in the sense, well, GF is not bidirectional.
No, I mean GF is bidirectional, or like. I mean, GF is you write linearization and then you get parsing for free.
Okay.
Like,
Mhm.
like so. I mean, actually, if you tomorrow morning, I'm going to show you how the GF is compiled. Like what's the format it's compiled to. So we can actually take a sneak peek. I have proper slides for it, so like it's not going to be as messy as this, but like if I take PG, it's short for print grammar. This is going to be a bunch of strange symbols. So okay, that's the Afric syntax, and we have productions just like in. So like I mean, you can see that this is like. I mean, you don't need to know what these C's and F's mean, but like certainly you see that okay, there is a lot of ways of making C10 whatever it is. Actually, C10 is VP, but like and you can make it so C1, C2, C3, C4, C5, C6 to C9, they are all NPs because that's I guess okay, sorry. I guess C10 must be the S and C12 is actually. No, it can't be. I don't know. But anyway, the point is that like these things definitely expand to something like several ways of making one thing. Like here we had such NP can be one of these, or like these verb third person singular verb is like one of these, and other verbs one of these. So this is like the low level is going to be like that's where all this kind of expansion is happening.
No, but all I wanted to say is in the teacher grammar, you do not have to make it explicit where or how the flow of information is organized. So
Right.
you say, well, the number in the verb phrase and the noun phrase have to be the same. Whereas in GF, you explicitly say, well, for example, the verb phrase is singular, and then I take it over to the noun phrase.
This is like in this line we're choosing the right form of the verb phrase based on the agreement of the subject. So like if we look at L-table compo v2 C so this is a table with like the S has C's and C, and then the compo has all of this is food. I mean, I don't have any more content for today, so like if you want to ask something, remark anything, like
So who is this NLTK from?
actually, I don't know. Like, it's just the NLTK. Like, it's been around. Like, when I was an undergrad 15 years ago, we did NLTK. So, like, that's an old thing. Like, it's GF is 23 years old and it's version 3.11, but this is like 3.6.2. But that's not a good heuristic.
Okay. The singular themselves, in what context?
I mean, that's the gender neutral. Like,
because I thought in English we always have themselves.
I mean, it's the language is kind of in flux, sort of like in some context. Like let's just Google like themselves. What do we find? Like, Okay, we just find definitions. Yeah, okay. Both themselves and themselves are acceptable as reflexive singular pronouns. However, themselves is currently the more common usage. Okay, yeah, sure. Yeah, we can definitely change it to whichever. I just kind of wanted to make this inflection table be like more sort of more variety. Commit this Python and we have any more audience today? Yeah, so if no more comments, we can just end here. And well, I guess there is no lunch in half an hour, but we can do whatever.
Okay.
Yeah. Thanks for your attention.
Yeah.
This was the talk that was not about GF, so it's like
No, but I think the comparison was interesting.
Yeah.
I see the difference in like the two languages, but is there like cases like what would NLTK be a better use for?
Yeah. What would NLTK be the better use for? Like, yeah, exactly. So NLTK in general has like lots of like tag corpora, like lexica. It's integrated to like word. It has word integration, and I actually don't know that much. Like.
NLTK is the one that has got like certain, so you can calculate with the corpora and the matrix that come out. You can calculate certain similarity.
Yeah,
Then
I
you
would
can,
expect
like,
it.
for example, you can match for how well correlated they are, especially in like the job application and JD.
So maybe like NLTK would be better for like if you don't care so much about how grammatically accurate your sentence is. But
Yeah.
like it's got like different parts that you can compare or something.
Yeah, I guess like I really have very little clue what people are using like this part for. Like I know like the whole NLTK is a wide variety of things, but
Correct, that one was one or two that I know, but I think that could be other more.
like in general, like so context-free grammars are like, well, you write programming language descriptions, definitions in those, like Alex, happy, PNFC, that kind of stuff.
I think with the NLTK, we can narrow down to a certain group. Okay. And then, yeah, then there was also, a friend did generate certain content with those groups as well, one of the projects. Just about some of the memories from 3 years ago.
Yeah, I know, like, I mean, I learned NLTK when I was an undergrad, and then when I was TAing undergrads, when I was a PhD student, they also used NLTK, but there was all this kind of like, yeah, corpora tags, sentiment analysis, like, I don't know, like, yeah, more mainstream NLP rather than like hardcore grammar engineering, which is, yeah.
Yeah, but I mean, even though maybe there's not a formal translation from GF to NLTK or vice versa, I think, well, the fundamental problems are probably the same if you model a particular language. Or do you think that NLTK applies you to model things in a totally different way? So if you take an exotic language that already exists in NLTK, you think would be worthwhile to look at how it's been done there.
Yeah, I mean, I need to say that, like, when you say NLTK, like I don't know if there is actually any real, like, does the NLTK toolkit actually provide these grammars? Like, I don't know if these are anything more than toys, but like more general, maybe like if a feature structure context-free grammar, if there are big those written for other languages, like. I mean, I didn't think, like, I mean, I could probably, yeah, if I had a resource like that, I can see myself like looking at it and then going like, I make these into parameters in my GF. Oh, that's useful. Now I know what kind of parameters to include.
Yeah.
It's like that would definitely be useful. Yeah.
I'm just thinking now, you say that NLTK allow more free-form thinking because it has those tokenizing features. So
Yes.
like you can do topic modeling or the sentiment analysis.
Yeah, I think, I mean, like we're kind of like, when we say NLTK, like, are we talking about this whole big, super wide, big library, or just the context-free grammar writing facility? Like, we're like, I'm just. But yeah, I mean, that's because I gave you that answer, so sorry, I was confusing. So like, yeah. But yeah, so to conclude, I would be very happy to see this type of grammar as an inspiration to write a GF grammar. Like, it would not be a waste of time if that existed already. Like, shall we call it a day? Go for lunch. Yeah. Okay. So, so we're